We've got a big news alert coming out of the United States of America. In yet another shooting incident, multiple people have died and many injured in California.
We begin now with the string of gun violence across the country this weekend. Between Friday and Sunday, at least 10 cities reported mass shootings. Those are shootings with 4 or more victims.
Warm greetings to all the teachers. My name is Ruchika Sharma and my roll number is 101806020. I am from Electronics and Communication branch.
My name is Nitesh and I am from ENC branch.
I am Guneet from ENC branch.
My name is Pallavi Garg and branch ENC.
My name is Nehal Arora and my branch is Electronics and Computer Engineering.
Now coming to the project description. We have divided the project into 3 parts: gun detection and classification, distance estimation, and direction estimation. Gun detection detects any guns present in the video. Distance estimation and direction estimation combined give the location of the shooter. Now moving on to the gun detection model. The input video taken from the camera is used to monitor any guns in the vision perception. The video inputs are fed into a pre-trained machine learning model which highlights any guns in the frame using the YOLO V3 model. This feature recognizes guns in the video and forms a bounding box around the detected guns. So this is how the guns are detected and a bounding box is formed around them. Now moving on to the gun detection and classification. The detection problem is addressed by reformulating it into a classification problem. The solution employs You Only Look Once YOLO V3 model, which is a deep learning framework based on darknet. It is the best choice because it provides real-time detection without losing too much accuracy. The architecture used is darknet 53, which consists of 53 convolutional layers, each followed by rekey, redo activation, and batch normalization layers, which makes it a fully convolutional network. Now moving on to distance estimation. The bullet generates 2 sounds: acoustic muzzle blast, which is caused by barrel explosion, followed by a shock wave. This forms a conical waveform. The distance of the shooter is estimated by calculating the angle of arrival at each input point by measuring the time of arrival. We then calculate the position using simple physics and geometry by taking the time difference between the two waves arriving. The estimated coordinates of the shooter are then depicted on a geographical map. For direction estimation, we need a pair of synchronized videos. The bullet generates 2 sounds, shockwave sound and the muzzle blast sound. The distance of the shooter from the camera is estimated based on the time difference of these 2 sounds. A possible range of the location of the shooter is indicated, from which we determine the most accurate position. The system uses the time difference of the arrival of the muzzle blast sound at the 2 cameras. Now here we can see that this donut-like shape is formed with the help of distance estimation, whereas these hyperbolas are formed with the help of direction estimation. The overlapping area between these two indicates the region of high possibility of the location of the shooter.
As you can see on the screen, this is the API for our project. First, we will upload a video on our gun detection model, and we will wait for it to be executed. You can see on the screen that there is a pop-up window, and you can see that there is a bounding box around the rifle as it successfully identifies the rifle. Now let us move to the next part, that is the shooter localization part. For this part, we need at least 3 or more videos to be uploaded in our system. through these videos, we will try to reconstruct the events, and the video will be synchronized in the background. Now we will execute our model. The output for this model is going to be a pop-up window on a map, in which you can see that there are two things. One is the donut area and the second is the hyperbola. The donut area tells us the distance estimation of the shooter's location, whereas the hyperbola tells us the probable direction of our shooter.